All right, let's take a look at the practice test. For the instructions, we're asked to write in slope-intercept form and standard form. All right, for problem 1, we're given m, which is our slope, is equal to 1/2. We are given our y-intercept, which is going to occur at 0, -3. So if you get this information and you're asked to write in slope-intercept form, it's going to be really easy because you can basically just plug in. So let me write this out for the first one. So the slope, we'll say intercept form of the line is y is equal to m, your slope, times x plus b, where b is the y coordinate from your y-intercept. Okay, so this is really easy to do. All you would say is that, okay, m is 1/2, so I'm going to plug that in there. So I'm going to plug in a 1/2 there. And then b, the y coordinate from the y-intercept, is -3. So I'm going to plug in a -3 there. So what would that look like? You would have y is equal to 1/2 x, and then instead of plus -3, let's just write -3. So when we inspect an equation of a line in slope-intercept form, we immediately know that the slope is 1/2. It's the coefficient of x. We also know that the y-intercept is going to occur at 0, b, where b here would be -3. Okay, so the sign comes with that. You could write that again as plus -3 if you wanted to. So that is the easier guy to get. You also have what's called the standard form of a line, which can be a little bit tricky because the definition is going to vary based on your textbook and also what level of math you're studying. So let me just write out the standard form like this. So this is ax plus by is equal to c. Now, if you're studying math at a high level, typically when we say the standard form, we would say that a, b, and c are just real numbers. So it really wouldn't matter what they are. So just to do that really quickly, let's write out y is equal to 1/2 x minus 3. So I'm just going to subtract 1/2 x away from each side of the equation. Over here, this is going to cancel away. And so this would give me, let me put a little border here, -1/2 x, and then plus y, you could write plus 1y if you wanted to, is equal to -3. So you see how things match up here. A here is -1/2, b here is 1, and c here is -3. Typically, you're going to see a stricter definition. So what they're going to say is that a, b, and c need to be integers. There's no common factor between a, b, and c other than 1, and that a needs to be non-negative. Okay, so how can we accomplish this stricter definition? Well, the first thing is you notice that you have a fraction here. So it's -1/2, and also it's negative, right? So we need to take care of both of those things. So what I could do is I could multiply both sides of the equation by -2. So let me do that over here. And let me do that over here. You put this as a -2 there. And the reason I'm doing that is because the 2 would clear the denominator, okay, because 2 times 1/2 would be 1. And then by making this negative, a negative times a negative will give me a positive. So I'm going to take care of both of those things, right? So I will have a non-negative value, and I'll also have an integer. So let's go ahead and say that -2 times -1/2, and then times x. Of course, that's going to end up giving me 1x or just x. We'll do that in a moment. Then plus, this is going to be -2 times 1y or just -2y. And this equals -3 times -2. That's going to be +6. Okay, so what I'm going to do here is just cancel this out completely and just say that that's 1. So let's write our answer here in standard form and say it's x. You can go plus -2y, but typically we'd say -2y is equal to 6. All right, let's take a look at problem 2. So here we're given the slope m being equal to 1. And then now we have a point on the line that's not the y-intercept. It's 2, -2. So you saw before that we were given in problem 1 the slope and the y-intercept. So if that happens, you can plug straight into the slope-intercept form of the line. So y equals mx plus b. But we can't do that here because we don't have enough information yet. So what you're going to rely on is another form of the line, which is called point slope form. So we're going to use point slope form. And you use this whenever you have the slope and a point on the line that is not the y-intercept. And then you can also use it if you have 2 points, and I'll show you that later on. Okay, so from point slope form, what you're going to have is y minus y sub 1 is equal to m times the quantity x minus x sub 1. And basically the given point is going to be x sub 1 comma y sub 1. So this is x sub 1 and this is y sub 1. So let's comment down here and I'm just going to plug in. So we would say that y minus, for y sub 1 you have negative 2. So be really careful. Minus a negative is plus a positive. So let me write this like here first, and then I'm going to change this over to plus 2. Then over here for m, it's going to be 1. So you could write it, or you could leave it off because 1 times anything is just itself. So I'm just going to put it here for clarity. And then for x sub 1, that's going to be 2. So let's put that in there. Okay, so all you really have to do is solve this for y, and you're back to the y equals mx plus b, or the slope-intercept form that we're trying to find. So let me get rid of this and slide this down a little bit. And so I think what I could do here is just drop the parentheses, because again, multiplying by 1 is not going to change anything. And then you could just subtract 2 away from each side of the equation. This will cancel away. And what you're going to have is y is equal to, you have x minus 2 minus 2. So negative 2 minus 2 is going to be negative 4. So y equals x minus 4. So this right here is now going to be the slope-intercept form of the line. Again, it's y equals m. M here is 1, right? If you have just x by itself, it has an implied coefficient of 1. So y equals mx plus b. So the y-intercept would occur at 0, negative 4, and the slope is 1. Okay, let's go ahead and put this into standard form now. Let me move this up here. Again, that form is ax plus by is equal to c. And so let me slide this over here a little bit, put a little border. And I'm just going to write that this is the standard form like this. And basically, I'm going to subtract 1x away from each side of the equation. This will cancel away. You'll have negative 1x, or you could just write negative x if you want. And then plus y is equal to negative 4. Again, depending on the level of math you're studying, this might be acceptable. But typically, you want a, b, and c to be integers, which we have here. And then you also want a to be non-negative. So we don't have that here. Right now, this guy right here is a negative 1. So what most teachers would ask you to do is to multiply everything by negative 1. So let me do that over here. So this times negative 1, and then this side times negative 1. And so it's just going to change the sign of everything. Negative 1 times negative 1x would just be x, or you could put 1x if you want. And then negative 1 times y would be negative y, so let's write minus y. And this equals negative 1 times negative 4 would be positive 4. So in standard form, we're going to get x minus y is equal to 4. All right, let's take a look at problem 3. So here we're given 2 points on the line. So we have negative 5, negative 4, and then we have 4, 0. So what you want to do in this situation is use your point slope form to get the slope-intercept form, and then from there you can get your standard form. So how do we use point slope form? Let me write that up here again. Point slope form. So y minus y sub 1 is equal to m times the quantity x minus x sub 1. Well, we have 2 different points on the line, and we could choose either one to be x sub 1, y sub 1. But what we don't have right now is the slope. So if you're given 2 points, unfortunately, you do have to go through the slope formula and generate the slope. So m, the slope, is equal to y sub 2 minus y sub 1 over x sub 2 minus x sub 1. Let me slide this down here real quick. So I'm just going to label this. Let's say this is x sub 2 and y sub 2. And let's say this is x sub 1 and y sub 1. And just plug in. So for y sub 2, we have 0. For y sub 1, we have negative 4. Be really careful. Minus a negative 4 is plus 4. And then down here for x sub 2, you have 4. And then for x sub 1, you're going to have negative 5. So minus a negative 5 is plus 5. So what do we get? 0 plus 4 is 4. And then 4 plus 5 is 9. So the slope m is going to be 4/9. Okay, I'm going to erase all of this, and I'm just going to drag this down here. And actually, let me write this over here. So m is equal to 4/9, so we don't forget that. And I'm just going to plug in. We can get rid of this. I don't need this anymore. For m, I'm just going to say that this is 4/9. So 4/9, and then times the quantity again, x minus x sub 1. Maybe I can move this up here a little bit, and maybe I can make this a little bit larger. So y minus y sub 1. Now, here's the part that kind of confuses people. You saw a moment ago that I labeled this as x sub 1 and y sub 1, and this is x sub 2 and y sub 2. That is just for the purpose of getting slope. Once that's done, you can use either of these points as x sub 1 comma y sub 1. It does not matter. When you solve for y, you're going to get the same exact thing. Okay, so I'm just going to pick this one as x sub 1 and then y sub 1. If you want to pick this one, it'd actually be a little bit easier. Actually, I'll just do both of them and just show you that it works out either way. But basically, let's start with this one. So I'm going to plug in for y sub 1. This is -4. Minus the -4 is +4. For x sub 1, it's going to be -5. So minus the -5 is +5. So solve for y. You're going to get y plus 4 is equal to 4/9 times x is 4/9 x. And then plus 4/9 times 5 is going to be 20/9. Okay, let me actually get rid of this. And let's think about solving for y. So all you need to do is subtract 4 away from each side of the equation. We'll get rid of this from over here. And let me write this up here so it's a little bit more clean. Y is equal to, you have 4/9, so 4/9 times x. And then basically you have plus, I would get a common denominator here. So I'd multiply this by 9/9. So we'll say 20 minus 4 times 9 is going to be 36. And this would be over the common denominator of 9. Okay, so let me get rid of this. So 20 minus 36, that's going to be -16. So you can go ahead and say that this is minus 16/9. Okay, so that's your slope-intercept form. Now, as promised, let's say that you had decided to pick this as x sub 1 and y sub 1. Well, again, just plug in to the point slope form. So you have y minus y sub 1 is equal to m times the quantity x minus x sub 1. So for y sub 1, I'm plugging in a 0. For m, I'm plugging in a 4/9. And for x sub 1, I'm plugging in a 4. So right now it looks different, but again, when you solve for y, you'll get the same thing. So this right here, y minus 0, you can get rid of that. You just have y. Let me slide this down just a little bit. And I'm going to distribute this to each guy here. So y is equal to, you'd have 4/9 times x, which is 4/9 x. And then minus, you have 4/9 times 4, which would be 16/9. So let me get rid of this. And you can compare the two, and you see that you got the exact same thing. This one was less work because there was a 0 involved, but again, either way, you get the same answer. Okay, so this is the slope-intercept form. Now, let's find the standard form. So again, let me put a little border here so everyone's reminded. It's the ax plus by is equal to c. So what I'm going to do is subtract 4/9 x away from each side of this equation. And so over here, it's going to cancel, and that's going to give me -4/9 times x, and then plus y is equal to -16/9. Okay, let me actually get rid of this and scooch this up. Now, if we're going to go with the stricter definition, remember we want a, b, and c to be integers. Here, your a is -4/9, so that's a fraction, and your c is -16/9, so that's also a fraction. Additionally, you want a to be non-negative. Here it is negative. So how can we fix both of these problems? Well, basically, the LCD is 9. So if I multiplied both sides of the equation by 9, the denominators would get cleared, so you wouldn't have any fractions anymore, but it wouldn't fix the problem of this being negative. So to fix both problems, let me just slide this down here so we have enough room. I'm going to multiply both sides of the equation by -9. Okay, so -9 times this, and then this times -9. Let me slide down here, and let's go ahead and distribute this like this. So you'd have -9 times -4/9. Then times x, then plus -9 times y. Let's just write -9y. And this equals, you have -16/9 times -9. We know that a negative times a negative would be a positive, and you can cancel this 9 with this 9. Let me show the negatives as canceling here. So you're left with 4 times x, or just 4x. Then you have plus -9y. You could just write that as -9y. And this equals, over here, again, negative times negative is positive. Let me show those negatives as canceling and becoming a positive. And so basically here, 9 divided by 9 would be 1. So you're just left with that 16 there. So this is 16 here. So you get 4x minus 9y equals 16. This is going to be your standard form. All right, let's take a look at problem 4. So here we're given 0, -4 as a point, and then -3, 0 as a point. So we do actually have the y-intercept here at 0, -4, but you don't have the slope yet, so you can't immediately plug into the slope-intercept form. You need to get the slope first. So let's say m is equal to, let's label this as x sub 1 and then y sub 1. This is x sub 2 and this is y sub 2. Let me scooch this down just a little bit here. We'll say this is y sub 2 minus y sub 1 over x sub 2 minus x sub 1. Okay, just plug in. So for y sub 2, we see we have 0. And then for y sub 1, we have negative 4. Again, minus a negative 4 is plus 4. Then for x sub 2, it's negative 3. And then for x sub 1, it's going to be 0. So negative 3 minus 0 is just negative 3. So get rid of that. And then 0 plus 4 is just going to be 4. So this really is going to be negative 4/3. Let me get rid of this and just say this is negative 4/3. So at this point, you could just plug in to the slope-intercept form and be done. So it's y is equal to m the slope, which is negative 4/3, times x, and then plus b, which again is the y coordinate from the y-intercept. So this is negative 4. You can go plus negative 4, or typically we just put minus 4. So that's your slope-intercept form. Additionally, you could have also still used the point-slope form, right? You get the same thing when you solve for y. So y minus y sub 1, let me put the 1 down there, is equal to m times the quantity x minus x sub 1. And let's say that I use this as x sub 1 and y sub 1, or you could use this one, it doesn't matter. If you plug in for x sub 1, you would have a negative 3, and minus a negative 3 is plus 3. If you plug in for y sub 1, this is 0. And then if you plug in for m, it's negative 4/3. So y minus 0 is y. And then you would basically have, let me put the equals down here and get rid of this, negative 4/3 times x, and then 3 times negative 4/3. The 3's would cancel, and you're going to be left with negative 4 there. So you see that you get the same answer. So y equals negative 4/3 x minus 4. Okay, let's get rid of this. And of course, you can plug this one in. You get the same thing. If you want to try that on your own, it's up to you. Let me get rid of this and get rid of this. We don't need this anymore. So now we want to find the standard form. Okay, so let me write that over here again. ax plus by is equal to c. So I'm going to just add 4/3 x to both sides of this equation. Over here, this is going to cancel away. And then I would have 4/3 x plus y is equal to negative 4. Let me change this and make it a little bit better. Again, depending on your class, and I can't say this enough, this might be okay. But mostly, you want to make sure that you don't have any fractions. So you're dealing with integers for a, b, and c. There's no common factor other than 1. And this guy right here is non-negative. Right now, it's a positive value. So we're okay there. But we do have a fraction. And to clear that, you can just multiply both sides of the equation by 3. So let me distribute that in like that. And then basically, you would have 3 times 4/3 x plus 3y is equal to negative 4 times 3. Let me put a multiplication sign there so that's clear. That's going to be negative 12. So this right here is going to cancel. And then basically, you would end up with 4x plus 3y is equal to negative 12. So that's the standard form of the line. All right, let's take a look at problem 5. So here we're given m, our slope, being negative 2. And then we're given a point 1, 0, which happens to be the x-intercept, but not the y-intercept. So if we had the y-intercept, we could plug straight into the slope-intercept form, but we don't have that. So I'm going to label this as x sub 1, and this is y sub 1. And I'm going to plug in to the point-slope form of the line. So y minus y sub 1 is equal to m the slope times the quantity x minus x sub 1. So for m, we know that's negative 2. For y sub 1, that's going to be 0. And then for x sub 1, that's going to be 1. Okay, so y minus 0 is just y, so get rid of that. Let me slide this down a little bit. And then this is going to get distributed to each guy here. So you'd have y is equal to negative 2x and then basically plus 2, right? Negative 2 times x is negative 2x. And then negative 2 times negative 1, you can go plus negative here to make that clear. That's going to be positive 2. Okay, so y equals negative 2x plus 2. That's going to be your slope-intercept form. So the slope here is negative 2. We know that. And the y-intercept would occur at 0, 2. Okay, let's get rid of this. And let's go ahead and put this one in standard form. So this one's actually going to be really easy. So ax plus by equals c. If I add 2x to both sides, I'll basically be done. So let me add 2x over here and add 2x over here. And so this is going to cancel away. And you're going to end up with 2x plus y is equal to 2. So I have a, b, and c. Those are integers. And a is non-negative. And there's no common factor between a, b, and c other than 1, right? So you have a 2 here and a 2 here, but this is a 1 here, right? So you basically can say that this is in standard form using your stricter definition. So 2x plus y equals 2. All right, let's take a look at problem 6. Here we have m, the slope is 3/2. And we have a point on this line that's 2, 4. Again, I'm going to use the point slope form here. So x sub 1, and then y sub 1 is how I'm going to label this. Let me slide down here a little bit and say we want y minus y sub 1 is equal to m times the quantity x minus x sub 1, and just plug in. So m is 3/2, y sub 1 is 4, and then x sub 1 is going to be 2. So I'm going to distribute this first. You slide down here a little bit and say we have y minus 4 is equal to 3/2 times x is just 3/2 x. Let me go plus negative to make this clear. You're going to have plus 3/2 times negative 2. So we know that 2's would cancel, and basically you put a negative 1 there, so negative 1 times 3 would be negative 3. So let's just go ahead and say that this is y minus 4 is equal to 3/2 x, and then again this would be negative 1 times 3 or negative 3, you can put minus 3 here. And to finish this up, I'm just going to add 4 to both sides of the equation. I'm going to cancel this away from over here. And we'll just say our slope-intercept form is y is equal to 3/2 x, and then negative 3 plus 4 is going to be 1, so plus 1. So here I know my slope m is 3/2, again the coefficient of x, and the y-intercept occurs at 0, 1. All right, so putting this in standard form, let me write this out over here again. So ax plus by equals c. So I'm going to subtract 3/2 x away from each side of the equation. Let's cancel this away. And then I'm going to say that we have negative 3/2 x plus y is equal to 1. So for the stricter definition, again, we want this to be non-negative. Right now it is negative. And then we also want it to be an integer. Okay, so what I would do to accomplish both of those at the same time, I would multiply both sides by negative 2. Okay, because the 2 would cancel with the 2 there, and then negative times negative would be positive. So let me do that over here so that it's legal. And so this is going to get distributed to each guy here. So negative 2, let me write this out. So negative 2 times negative 3/2 times x. And then plus, you're going to have negative 2 times y. And this equals, let's just do 1 times negative 2 now. We know that's negative 2. So here your 2's would cancel. And basically the negatives would cancel. So negative times negative is positive. So this is just going to give me 3x here for that part. And then you have plus negative 2y. Let's just write minus 2y. And this equals negative 2. So that's your standard form for the line. All right, let's take a look at problem 7. So here we have 0, 3 and 5, 0. So we do have the y-intercept that occurs at 0, 3, but we don't have the slope. So I'm just going to generate the slope real quick. So this is x sub 1, y sub 1. This is x sub 2, y sub 2. Again, you could change the labeling, whatever you want to do. Let's say m is equal to y sub 2 minus y sub 1 over x sub 2 minus x sub 1, and just plug in. So y sub 2 is going to be 0, and then y sub 1 is going to be 3. And then here x sub 2 is going to be 5, and then x sub 1 is going to be 0. So 0 minus 3 would be negative 3, and 5 minus 0 would be 5. So this gives me a slope m, which is equal to negative 3/5. So the fast way to do this is just to use the y-intercept here, which is 0, 3, and just plug in, right? So y is equal to m, the slope. We have that. That's negative 3/5 times x, and then plus b. That's the y coordinate from the y-intercept. So 0, b. In this case, b is 3. So plus 3. Okay, so that's all you really need to do. If you wanted to use the point slope form, you can label either of these points as x sub 1, y sub 1, and then just plug into the y minus y sub 1 equals m times the quantity x minus x sub 1, solve for y, and you're going to get the same thing. So let's slide down here. I'm just going to put this in standard form. Let me put this over here so nobody's lost. So ax plus by equals c. We're going to add 3/5 x to both sides of the equation. I'm going to cancel this away. And then we're going to say that we have 3/5 x plus y is equal to 3. In some classes, this is enough. But in most classes, especially if you're in high school, they're going to ask you to get rid of this fraction here. Okay, so you can just multiply both sides of the equation by 5 to clear that denominator. So let's go ahead and do that real quick. And we'll say that this is going to be multiplied by this and this. So 5 times 3/5, let me write that out so nobody's lost. And then times x, and then plus you have 5 times y. And this equals 3 times 5 is 15. We know that this is going to cancel with this. And so you end up with 3x plus 5y is equal to 15. So that's the standard form for the line. All right, let's take a look at problem 8. So here we're given 2 points. One point is 0, 0, which is the origin, and the other point is -1, -3. Now, if your line passes through the origin, it's going to look like this in slope-intercept form. So y is equal to mx, because the y-coordinate from the y-intercept is 0, right? So plus 0, you can just leave that off. Additionally, if you looked at it in standard form, it would look like this. ax plus by is equal to 0. Okay, so we're going to see this in a moment. So what I would do here is, again, just find the slope, and you can label this as x sub 1, and this is y sub 1, and this is x sub 2, and this is y sub 2, and then just plug into the slope formula. So m is equal to y sub 2 minus y sub 1 over x sub 2 minus x sub 1. So y sub 2 is -3, and then y sub 1 is going to be 0, and then x sub 2 is going to be -1, and x sub 1 is going to be 0. So basically, you can get rid of the -0 in each case. You have -3 over -1, which is basically going to be 3. So that's your slope. Let me write that over here. So m is equal to 3. And then writing this in slope-intercept form is really easy. You're just going to say y is equal to m the slope, which is 3, times x. And then again, you would go plus b, but b here is 0, so you don't need to put plus 0 because that's not going to do anything. So it's just y equals 3x. Now, to put this in standard form, you would just subtract 3x away from each side, right? Because again, let me write this out so nobody is confused. You want the ax plus by is equal to c. So we would say that this is going to cancel and become 0, okay? Because nothing else is on this side, I need to make sure I write a 0. A lot of times people will cancel that out and put nothing, and then they get lost in terms of what to do next. So this is gone, and I'm going to put a 0 there. So now I have -3x plus y is equal to 0. Okay. Now I don't want this to be negative if I'm using the stricter definition, so I'm just going to multiply both sides by -1. So this is going to get distributed to each guy, and multiplying by -1 just changes the sign. So you're going to end up with -1 times -3x, that's just 3x. Then -1 times y is just -y. Let's just put -y like this. This equals 0 times anything is 0, so let's just put 0 there. So 3x minus y equals 0. That's going to be your standard form for the line. All right, for the next few problems, the instructions are going to change. We're asked to find an equation of the line. So here for problem 9, we have a 0.5 comma -4, and then another 0.5 comma 3. So immediately what you should notice is that the x value is the same in each case. So if you try to get the slope here, you're going to get an undefined slope, because when we have the slope formula, m is equal to y sub 2 minus y sub 1 over x sub 2 minus x sub 1, well, the x values are the same, right? Typically with the slope formula, you write off to the side that x sub 2 is not equal to x sub 1. But here they are equal, right? Because if I do 5 minus 5, I'm going to get 0, and division by 0 is not defined. So when you see this, you know that you have a vertical line, right? So it's just x is equal to whatever that x value is that occurs here and here. So in this case, it's going to be 5. So this is just a vertical line, x equals 5. All right, now we're looking at problem 10. And here, m, the slope is 0, and we're given a point 0 comma -4. If you have a slope of 0, that means you have a horizontal line, and basically, you can just take that y-coordinate from that point that you have and say that y is just equal to -4. So it doesn't matter the value of x in this particular case. When you graph this guy, y is always equal to -4, so it's just a horizontal line.